Okay, sir. I, Deepa of St. Joseph College of Engineering, belongs to E&A department, and I would welcome our Mr. Special guest, Mr. Gautaman, for giving his valuable speech. So once again, I always will give a very good. He will give a very good speech. We have seen in him in our college value-added courses. So on behalf of our St. Joseph College of Engineering, I would first thank our chairman who has given us valuable opportunity to conduct all these webinars and during this lockdown period. So a brief introduction about our sir speaker, Mr. Gautaman. He's a graduated in electronics and communication engineering, and he has done a double master's degree both in electronics as well as in management courses. So human resource management is his specialist. So he's a member of International Society of Automation and also a member in Instrumentation Society of India. He is a certified radiology safety officer by Atomic Energy Regulatory Board, Government of India. So now he's working in Chennai Petroleum Corporation Limited as a project instrumentation manager. He has a 25 years of experience in the project activities like design and implementation of field instrumentation and control system. He has commissioned more than 10 plant installation with DCS, PLC, and SCADA. And he is taking his valuable time to spend with us to share his knowledge about emerging trends in embedded system and Internet of Things and process industry, which is a very lively subject now to be known for the industry 4.5 to occur. Thank you, sir. I once again welcome, sir.
Thank you, ma'am. Good evening, faculty members and the students community. The purpose of this session, 45-minute session, is to introduce or to refresh our knowledge what is happening in an industry and how these industries can be enhanced using the knowledge that we acquire during our curriculum. For example, what are the applications of embedded systems in Indian industries, and what are the applications of IoT? In what way this COVID scenario can change the activities of an industry, whether it is a positive side or negative side, we'll discuss about that. I'm just starting the presentation. Basically, India still a developing country, and we got plenty of industries. I'd say 25% of the industries are not yet modernized, not yet acquiring the capabilities of the modern electronics technology, wireless communication, and their advantages are not yet being derived to 25% of Indian industries. The rest of the industries slowly started utilizing modern developments that are happening outside of industries. Let it be software upgradation or sensors, most modern sensor technologies. And this is a comprehensive list of Indian industries. An engineering person may work in 4 of the engineering worlds, in my opinion. One is the design field, design of household articles, domestic appliances, or industrial appliances. It may be a compressor control systems or a remote telemetry system. Designing is a very vital field in industries. And then manufacturing. Manufacturing may be a mobile phone or any gadget that we use in our modern day, or manufacturing of industrial electronic products like a PLC or a distributed control system, or even a computer manufacturing industry. Then one more world where our engineers have to play or have to apply the knowledge is procurement area. Like when we started buying a mobile phone, we need to have a complete knowledge on various processors, what are their speeds, advantages, heat dissipation capacity, and so many parameters needs to be analyzed Based on that, we need to procure our mobile phone. The same way, in Indian industries, an effective engineer can enhance the performance of all the system by applying his knowledge during the procurement phase. Then comes the configuration. Once that material is in an industry and when it started working, we need to do so many configuration parameters, and this is one of the major application area for an engineer. We got plenty of field for the engineers to work with. The knowledge that are required to work in these areas are already covered in our 2017 curriculum. Okay, to start with, if I want to build a home, I need to undergo a certain processes. The same way, if I want to build an industry, there are certain activities. And till procurement phase, all those activities, most of the activities are in software form. Whether you design a three-dimensional plant or you analyze what is the pressure, temperature, level to be maintained in the particular process to fetch the required product, or procurement, comparison, analysis of various products like a pressure transmitter. If you want to buy a pressure transmitter or a temperature transmitter, there are plenty of transmitters that are available in the market. We need to analyze. So all these phases are in software. Hence, computers are used, and the use of external communication or from a cloud server, an expert can analyze all those parameters and he or she can derive better results if a powerful software and a hardware is combined. Once this procurement phase is over, then industries started building their plans. This is called erection phase. During the phase, based on three-dimensional software that developed, plans are being erected, and after that, we will test the plan. This is one particular area where most of the accidents are happening. There explosions, be it or remote controlled or monitored system to monitor what are the project activities. Are we going in phase with a plan, or is there any deviation, something like that? We need this activity also during erection. I would like to present three major areas where I have worked with, and I felt the need of embedded system and IoT. One area is our major backbone of our Indian economy is oil industry. From exploration, it starts. We know very well exploration takes place in remote areas where most of the time it is less manned. Hence, what is happening in that area needs to be, those data needs to be transferred from that area to a remote server or a cloud system. That would be a better idea of handling information. So this is one typical example where a risky operation is being carried out. Drilling a petroleum well and extracting the petroleum out of that risky business, usually placed in a remote village. Once that petroleum comes out of that, then it goes to a pre-processing plant where we need to separate oil, gas, mud, salt, water, and we have a wonderful measuring facility here to measure what is the quantity that comes out. These parameters needs to be monitored, controlled, and these data needs to be stored better in a cloud system. This is one typical example where we can apply IIoT. These pre-processing plants are also in remote areas. We got this information facility, a typical case. Then comes the petroleum to our refineries. Refineries are very complex plants which are handling, unlike the cement factory, which are handling combustible materials. And it's a costly business. It goes to the heater, goes to the distillation tower from where we separate the products. Either these products can be stored directly or sold out directly, or it can be sent out to other value addition plants. One typical equipment which plays a vital role in petroleum industry is a distillation tower, where the vapor goes in and various products are taken out, like LPG, diesel, etc.
Sir, your PPT is not seen.
Is it? Every slide or only one slide? I shown one slide so far.
Nothing seen, sir. Only your face.
I'm sorry.
Okay, sir.
Oh, hello. Is it okay now?
Yes, sir. Correct, sir.
Oh, you should have reminded me. Sorry. Okay. Any comments, sir? Sir, select one.
Yes, sir. Yes, sir. You can proceed.
Okay. Okay. So, distillation tower is a very basic equipment in an industry where vapor comes in and various products are being derived. Since I'm from a person from a power plant and petroleum industry, I'm just narrating example, a typical application for embedded system at IIoT. So we produce various products which are used naphtha is the basic product for all our petroleum products like PET and the ATF. Diesel for since this is an hazardous industry, less manpower is employed in that refinery, and informations are being collected from that refinery, being sent out to a remote location. Another typical example is the electrical power plant. From power generation to transmission distribution, and consumption. A wide network is established and various data are being collected in this area, right from power generation, power distribution, and at our end, our consumption. The same typical pattern is also applied to industries, electrical generation and consumption. This is also one typical process that I would like to explain. Water pump, feed water pump is pumping water to a boiler where we burn any fuel like LPG, fuel oil, fuel gas, or coal. This is an exothermic reaction which produces heat, and the water absorbs the heat and it is being converted into steam. There are various elements that are placed in a boiler. All those parameters needs to be monitored frequently. Frequently in the sense, presently the parameters are picked up for every 200 milliseconds. And we got a huge generator which is driven by steam, which has got a potential energy, high pressure and high temperature energy is used to rotate the turbine blade, hence that is coupled to a generator which produces electricity. The machines are running at a faster rate, 3000 RPM. Hence, any small mishap can produce a disaster in that industry. And we got a condenser which condenses steam back into water, and that water is being pumped through boiler feed water pump back into the boiler. Okay, not only power production, but also our transmission and distribution area also needs to be monitored remotely. Okay, these are the two major processes that I would like to present. And automation industry in our world starts very early. In 1968, General Motors, started this automation device, and then Modicon subsequently followed up and developed a fully developed relay-based PLCs, and the list goes on. The first industrial revolution started in the year 1784, and steam engine is invented. With that, we started powering up. So, till then, muscular power is used to do job. The second revolution is with an electrical power, and the third industrial revolution is with the power of microchip or a computer or a microcontroller. Any programmable device gave us the power to control from remotely. And now we are on the fourth era of industrial revolution called cyber physical systems. That means even in our domestic appliances like our air conditioner, refrigerators are all connected to the internet now. They are all picking up information and they are sending information to a cloud from where we can take up the information and process it based on our requirement. The role of embedded system is very vital in picking up data, sending it to a remote place, processes it, take out some useful information out of that, give back that information to the plant so that the particular plant or industry can perform better. For students, I would like to say there are certain areas where we can work freely in the sense without any charges. Those areas I'll cover up. Anyone who is interested in doing experiments in embedded system or IoT zone, myself and our college is also here to support you to clear any of your doubts or to debug any of your programs or circuitry if you are interested in. We can work out in these two areas. We can, if you want to take up any small experimental projects or problems in an industry, plenty are there. So anyone wish to take up a project or any experiments, please feel free to call me or our college. We will assist you. So these are the simple embedded system basics. We know very well that any system has got a dedicated functionality, but it can be programmable. Then it becomes an embedded system. One typical example for students community, the cheapest processor, the very powerful, very flexible processor I would like to present here is this, the Arduino. You can do plenty of experiments. It is very user friendly, and whatever the input that you want, like 0 to 5 from the transmitter, that can be converted to one. Very wonderful. Another powerful is Raspberry Pi. This is a little bit costlier for the students, but once you are well versed with Arduino, want to do more of data like video, audio, and this one is best. Okay, and for the software also, we got a wonderful IDE for Arduino and Raspberry Pi. In industries, we use powerful RTOS to pick up data, to control it, to monitor it. We got plenty of commercially available RTOS systems are there. Open source systems are also there. In industry, we don't use open source systems. We use proprietary softwares. So if you want to take up a project on IoT project in the sense, or to do experiments, if you want to learn or to have hands-on experience on this area, first we need to concentrate on these embedded systems. Embedded system give us the flexibility of having a sensor connected to a microcontroller.
Sir, we
Getting
can't hear your voice.
Madam, am I not audible? Hello? Okay. I'm just presenting the other slide once again. Once again, I'm just presenting the other slides. Sir, is the second slide coming up on screen?
Yes, sir. It's visible.
Okay. Okay. Let us take a typical example of a simple water treatment plant so that we, the group, can understand every factors. I'm just presenting this. Let us take a typical example and analyze what are the various processes, what are the sensors that can be connected to a remotely controlled systems. We got a freshwater pump and we got an aeration system, a gravity filter system is there, product pumping system, then goes to the product storage. These are all the simple engineering terms. However, we are taking out the water from well or some reservoir, we aerate it and we filter it and we pump it and we store it in a storage tank. That's it. Let us observe the various activities are designed and implemented by an engineer in these areas. It seems there is a computer, there is a program running in the computer. People are operating and monitoring various parameters from the computer. Then we got a remotely located programmable control system panel and a power hub. And a reservoir from where we extract water. So the feed water pumps from that location to the water treatment plant. This is where the water comes in, settles. If there are any debris, any dirt particles are physically separated, and we need to aerate the system. We got a aerators. This is an electrical system, heater based, agitator based systems. From there it goes to gravity filter. We have seen a small embedded system example from where an HMI terminal is being operated by the operator, and from the pump it goes to the overhead tank. This is a simple operation. What are all the things that are being happening throughout the plant is being monitored by a remotely located control system. Okay, taking that example, let us describe the various activities of an engineer in the field of embedded system. What you're seeing is a typical HMI terminal, a 21-inch screen embedded with a processor, a touch-enabled system, which is connected through optical fiber cable or Ethernet or RS-485. This system is interfaced with an existing PLC, which receives data and sends data. As you see, the operator has initiated one start process. Let us see what is happening. This information is remotely transferred and our RTU or remote telemetry unit, terminal unit, whatever it names, receives the signal and acts based on that. This is one application of either embedded system or PLC or any dedicated controller. We can use anything. This system is going to communicate to an electrical appliances by starting a motor. What is being pumped from that? Simple. To pump the water, we need to establish the connectivity from PLC to an electrical system, and this PLC needs to communicate to a remotely located control system. Water is received at our terminal. This is simply a graphical representation of what we have seen previously, the physical systems. Once again, our another control system receives the signal and switches on the heater. Here comes a flow control system. We got a sensor and a control valve system to control that. These are all the various sensors that are embedded onto the process, maybe on the pipeline or out of the pipeline, and we got a small another control system which measures the water flow, and accordingly there is a control element. As the water getting collected in a tank, the pump has started automatically, and water is pumped to a storage tank. Let us take this typical example. We have seen, okay, once the tank is filled or it is getting filled, all this information are being transmitted, and our terminal is getting those informations and being monitored by humans. What are the various small fragmented engineering activities in these industrial applications? One is design of SCADA and HMI terminals. Second is our communication topology protocols. Third, we need to physically connect our PLC. We need to wire. It need not be PLC also. Any dedicated controller or embedded system will serve the purpose. We need to program that, and then we need to procure various field instruments to measure the pressure, flow, temperature, oxygen, CO, CO2, so many parameters, and they need to be procured, installed, and configured. And we need to also have a control system which is a closed loop. So in what way this remotely located plant can give information to a cloud? 5 years ago, most of the industries are operating on their own. There were no requirement or demand for interconnecting. Say, for example, a petroleum industry, IOC, Indian Oil Corporation, has got 8 refineries in our country. Every refinery, they were running on their own. They produce certain products, and there were no interconnection between these refineries. In the same way, any person who produces, say for example, a soap, any brand, you name it, if that industry is being splitted in 2 states, they will keep on producing products irrespective of the requirement or a demand. But now, there is a need for integration of this various process industry in India. One, we need to look for profit now. Any industry for the survival, because of the international competition, we need to survive. So the profitability factors is playing very vital. Then environmental factors also playing now. Any industry which is about to start polluting our environment in any form is being closed by regulatory bodies. So in so many various factors are involved in this. Hence, Indian industries are in a position to increase the performance and to decrease their waste, effluents, pollutions level. Hence, we need an integrated system for that. And this one is a typical example for to meet that particular demand. We got various sensors which are picking up information from plant. These sensors are in turn connected to any controller, programmable logical controller, or supervisor controller data acquisition systems. In turn, management enterprises system, enterprise resource planning systems are also there. This is within refinery, or within a process plant. It may be a power plant or a cement industry or any fertilizer industry. Now, with the advent of Industry 4.0 or cyber physical systems, these informations are now connected to a cloud through various protocols or hardware. Let us take an example of mining. I'm just narrating what is happening in an industry and in what way we can understand the process, and if you become a instrumentation engineer and electrical or electronics engineer in an industry, you can apply your knowledge to enhance that process to make more profitable. That way, this is a typical example of Indian mining industry, wherein various factors are being picked up. This one is for oil and gas. Here also, we embed many sensors in the plant. They will be continually picking up signals, and in turn, they will be pushing that signals or informations into the cloud. These are the uh, typical examples where we can apply our IoT embedded system concepts so that the industries can gain benefit out of this. The same way, transportation. If we want to transport certain materials, we need to monitor the ambience of the material inside the cabin and the position of the cabin. All those informations can be picked up using sensors. You say moisture inside the cabin, or temperature, or the pressure, or the location of the vehicle. Everything can be picked up, and then we can put all those information into remote servers. Okay. Plenty of servers are available, and the Indian industries are utilizing the power of the cloud nowadays. Personally, I work with SAP and ThinkSpeak. Okay. So we got plenty of protocols that are available on the market. We need engineers in the present day scenario who has got knowledge on these areas, who can work in PLM, MRP, or who knew the concept of protocols, who can handle that. That is the requirement of this hour for the Indian industry. I request the students community to take up these areas where, because these are all got less competition actually. A person with a PLC experience, programming skills, we got plenty of persons available on the market. However, these industrial Internet of Things or communication knowledge in these areas are very rare to find. These are all the areas slowly booming up. I request students community to take up these. And the knowledge that another area is augmented reality. If you are using a augmented reality software to train persons, say for example flight simulation or car simulation, or how to handle a boiler in an emergency when the steam pressure increases, people used to panic, and they behave in an erratic way that creates more cumbersome processes. Instead of opening a drain valve, they are starting some other pump, or that is the human nature. we need to train human in these critical areas. So augmented reality tool can be used to train operators, engineers to handle emergency, or the standard operating procedures can also be taught through this augmented reality. Okay, what is the gain of picking up the data from the sensors, putting it into cloud? One thing is artificial intelligence. These are all powerful tools. However, Indian industries are not in a position to invest huge money in buying heavy machines and to maintain them. What is the best alternative? Use already existing servers, take your data, put it into the server, let that artificial intelligence analyzes the data based on the outcome of this AI. We can operate our parameters in any industry. Plenty of artificial intelligence tools are also available on the market. Another area is big data. A typical power plant, 110 per hour generating thermal boilers, has got 2000 parameters to be monitored. Typically 1000 for analog parameters that are to be controlled, like level, pressure, temperature, something like that. Another 1000, they are all connected to programmable logical controllers or safety integrated systems, which monitors the healthiness of the system. In case if something goes wrong, it has to shut down the plant. That way, a typical power plant for a one boiler, we monitor 2000 parameters. Assume for every 1 second, I am picking up 5 samples of that. For a month, it will become a bigger data, and for a year, it is a huge data. So now Indian industries started using remotely located clouds servers to store this data. Anytime, from anywhere, we can fetch the data. So big data storage, transfer from our location to a server, visualization. That means instead of seeing the numerical numbers, if you see a trend graphical way, it will be better. Or we can query any past data in our required format. Any information needs to be secured privately. And big data analysis is one area where Indian industries just started using. And we got plenty of software for that. Okay, augmented reality, artificial intelligence, and big data, they are all the key advantages of having this IoT. So far, industries were using their own computers, their own PLCs, SCADA, distributed control systems, or dedicated controllers to monitor and control their activity. Now, we slowly started shifting our focus from having a local controller to a remotely located service. Okay, if students want to experiment this, Blink is the best application server for a student. It gives you the power of monitoring and controlling from your mobile phone. All we need to do is you interface all your process parameters to any embedded system. The embedded system, in turn, through wirelessly, can connect through the Blink server. You need to program the embedded system in terms of the parameters, factors, how your data array is going to be stored in Blink server. Then from Blink server, we can fetch the data anywhere in the world. Now, Indian industry started using this technology, not the Blink app, our own proprietary dedicated softwares. They are all collecting the information wirelessly. So for critical industries like ours, like oil and gas, atomic energy, power plants were feared to use this wireless technology because the reliability of the wireless technology was so poor 5 years ago. When there was a rain or the strong wind, we lose the data. Now, slowly, with a low power, they can able to design instruments. They can focus and concentrate data. So the reliability of the wireless system is also slowly improving. Indian industry started using this wireless sensors to connect the sensors to IoT. These are the major advantages of having an IoT platform. An intelligent sensor, unlike a dumb transmitter, which measures the flow or a temperature on that particular process and sends the data. Now we got plenty of intelligent sensors, which are not only measuring that particular process, but also their self-diagnostic data can also be transmitted. Whether the transmitter is healthy, whether the power electrical signal to the transmitter is healthy, is there any discontinuation or something like that. These bulk data can also be transmitted. That is one biggest advantage of having that. So, Internet of Things consists of machines, basically a pump, compressor, a furnace, or a heater, or a filter. Sensors are embedded with that. They pick up data and transfer. Then we got some tools that are available, packages which analyze the data and we process the data. Then these data are sent to users raw. What is the present value? Then the analytics takes out a big data, does the required functionality, then gives some information. Say, for example, there is going to be a power outage on Wednesday. So it is better to reduce our feed rate or better to increase the feed rate to compensate for the need. Some data like that can be derived from analytics and alerts can also be used. Say, for example, you cannot monitor all the parameters continuously. When there is a boiler pressure increases above the prescribed value, immediately your IoT can give you an SMS, can give you WhatsApp message or a mail. Okay, preventive maintenance. These are the next. Let us talk about the benefits of that. I'm just focusing not on the embedded system or IoT. I'm just focusing on parameters that are beneficial to industries so that students or engineers can focus on these areas so that our industry will get benefited. That is why I'm focusing on these areas. The benefit of IoT and embedded system is one primary advantage is predictive maintenance. We can able to say when our instrument or our system may fail or what is your demand for your product can also be predicted. You need not store a lot of spares in an emergency if you want to use or your feed rate. Say for example, for a power plant, we need water as a feed. So we need to store a lot of water. We need to build a reservoir. So industry, how many soaps we need to produce based on the demand. Inventory optimization can also be used. Why these kind of key parameters are now coming up? Why 5 years ago they were not there? Because now our industries are integrated with the real-time environment. Say, for example, if there is a war in any country, immediately that information our artificial intelligence can pick up, and based on that, it can say that is there is a war in that particular country. Your if any industry wants to connect their data into the internet, the first reaction from the head is it secure? For a distillation water plant or mineral water plant, there is nothing about security. However, if you think about petroleum industry, power sector, particularly atomic energy, then the risk of sabotage was there because the systems were not so secured an year before. Nowadays, we got a plenty of very good firewalls. Secured systems are emerging. Cisco, best example. However, are we 100% safe? No. That is one biggest challenge that we are facing in industry. Even your protocols, your hardware, your firewall are all placed well intact. In spite of that, there is a little bit of chance for a sabotage. That is one risk we need to consider. As a solution, Indian industries are now not connecting the critical parameters. All other parameters are being pushed to cloud, whereas only those critical parameters that plays a vital role. Say, for example, a feed water pump switch on or off control, or a boiler or a turbine speed control, something like critical parameters are not yet connected. Okay, so coming back to this IoT control of Blink for students, this is a very good platform. I would like to suggest two servers for our students community. One is the Blink, because I have worked with it. It is very good platform and it is easily configurable. All you need to do is just get one key, authentication token key from that server, put it in your program, and that starts connected. It will fetch or push data. ThinkSpeak is another typical platform for students to start their career. If you want to have an hands-on experience and want to experiment, this is the best tool. Blink app is for real-time applications. I would suggest if anyone wants to store longer data, say for example, I want to store 1 month data, and this is the typical example. ThinkSpeak, I'd like to suggest that. This is also very good tool. In industry, we use SAP or any proprietary systems for this IoT. However, experimenting or working on that area, you need to join an industry, then you start working. If you want to do any experiments, Blink and ThinkSpeak. I'm just because these two things I have worked with, and I don't feel it is there's no difficulty in that actually for using that. Okay, friends, the point is the need for connecting field sensors or even domestic sensors, your car or your bike data to be pushed into cloud. That is the need of the tower. Say, for example, in order to monitor your car's performance, car manufacturing companies are picking up the data from your car to their server. If there is any malfunction or if they predict there is a problem is going to happen in future, they alert you using these softwares. Slowly, these data around us, even our domestic appliances like a refrigerator, air conditioner, washing machine, they are also slowly picking up data and pushing those information into remotely control systems. Okay. This is just an introduction. I want to emphasize one thing. Industries need these kind of updates. They want to enhance their performance by adopting the electronics technology or communication technology that are available in the market. This is the best area where if any person wants to experiment or want to take up, or if someone says, I would like to present one more presentation, say for example, this. Okay, if some of you may say, I have an idea of an embedded system or of a IIoT, can I implement it in industry? The answer is yes. Myself and your college faculties will definitely help you to fetch a nearby industry where you can go and discuss with them. If you have any ideas, put that idea into a realistic model. They can implement it. As a result, yourself and the industry can get benefited out of this. Second thing is, some students or some of you, even the PhD scholars, may wish to take up a problem that are existing in an industry. And you take that problem, analyze it along with your faculty members, come out with a solution. This solution can definitely benefit the industry. Third system is, there is no problem, the system is already working fine, and industrial persons are thinking that yes, everything is fine, but still there is a scope for improvement in every system. If you have any knowledge, you can put that knowledge to improve any existing systems. I request this gathering to concentrate on this future era of Indian industries. They are slowly shifting from local controllers to remotely located cloud controllers. I have explained plenty of advantages for that. One thing is big data analysis. We can store a lot of data, put the data, analyze. Based on that, we can conclude. Then artificial intelligence, powerful software can also be made to run on this data. That can also fetch back to industries. So this is an opening session now. In the sense, IIoT platform is slowly booming up. COVID era is totally entirely transformed not only the software industries but also the process industries. We started working remotely now. All our softwares, previously we were afraid of using the software out of our industries. Now they're all connected in internet. We can fetch any data from anywhere now. So the COVID era transformed not only the software industries but also industries, process industries also. So now we need to think about where and all we can implement this IIoT powerful softwares. And I request students to interact with the faculties or anyone who is coming like this for you to interact with you, to take up your ideas, put into realistic model, and let the Indian industries gain out of this. Thank you.
Participants, you can raise a question now. Participants, if you have any queries, you can ask.
Or you can mail me or to Sankaran sir or to any faculty in our college. We will give you detailed answer. Yes, sir.
Okay. If no questions, then we can conclude the session. This is Sivakumar, professor in this department. First of all, I'd like to thank our management, start from our chairman, sir, managing director, principal, and dean for giving this opportunity for this webinar. And special thanks to Professor Gautam sir, though he is working with CPCL, in spite of his busy schedule, he has accepted invitation and he gave a nice presentation and things. And he has given insight knowledge and scope for improvement, and students who are willing to work in the area definitely help you. He is fond of teaching to students, and he is always like to teach more and more. Thank you, sir. Thanks for your valuable and wonderful lecture. And in future also, we are expecting the same from you. Thanks a lot. And
Thank you.
for participants, today's takeaway is you can have basic knowledge in this area, and you can start with this. All of you, thank you. Good night. Thank you, sir. Thank you.
Yes, sir. Yes, sir. Yes, sir. Sir. I'll go by one. Can you give any suggestion or idea to approach? Just who wish to take up any challenging problems in an industry can call directly to Shankaran sir. He will give my number and directly call me also. And can you send the picture? I will share the PPT with the Shankaran sir. One second. In my opinion, application is where you want to implement these communications. Whether you are going to do a research in the power plant or you take any of your nearby industry. Since I'm from industry, that is why I'm suggesting. There may be plenty of small scale industries also there. They may be also wish to take up this data to their home. Presently, they may not have any sufficient system, or they don't want to do any experiment on that. It may be a small scale industry nearby your residential area or nearby your college. You can approach plenty of applications are there. It may be the small molding units or any binding or small air compressor units are all here. Plenty of small industries are there in area, anywhere you take it. You can approach them, no problem. They will tell you plenty of problems, or they will tell you plenty of application areas where you go analyze what are the sensors needs to be procured for the particular application, and how you are going to interface these sensors to the computer system, and to which server you are going to connect. That is also designed based on the cost and the capability of the program. And yeah, and the factories and people in the industry are always here to help you to solve any problem that you face during the installation. IoT direct connect particular website or application is best. Point is, in whatever the way you connect your data to a server, it is through data communication. In terms of web or through app. Developing a website is not our job actually, it is already being developed. If you want to simply execute your job, you go for website based systems. If not, the website is already developed. Log the website. That's it. Then you want to if you start looking at that, you go for any app or if you are your mobile based website uh, developing app that will be yes sir. Any
Participant, fill the feedback form. Please fill the feedback form and you then go stop.